Thanks, Jan. Time will definitely be challenging for me. I have slides and demos and so on, but I will give my best. So I skipped my introduction as Jan already did this. Same with Trivalis. I think that has to be introduced. My agenda for today is I will give a rough overview about the situation. Then I will talk about Terraform, really Terraform in a nutshell, to give you a first idea why do we use this, what's this. Then I have a chapter with first steps. There is a bunch of slides. I will skip the slides and do hands-on and directly show them to you. So the slides are just basically as a reference for you for later review. Then I discuss a few use cases, good practice. And I will sum up with further considerations and the summary. Yeah, so in old days, I mean, I did this as well in early 90s, late 80s, built up my own PC, put together hardware. I think with cloud solution, we can do this now quite different. So there is no need to build up a server, put together hardware and care about do I have now disk storage, do I have this and that interface, etc. So if I use it, if I set up an infrastructure in the cloud, I have much more flexibility and I can use really other tools than just a screwdriver. Really, just as an introduction, OCI in a nutshell. I mean, if I work with OCI or if I start with OCI, I usually log into the console. I have different possibility then that I can create resources. I will start to create a compartment, and I create some network configuration, probably a autonomous database or a compute instance. So I can configure more or less everything through the web console. It's nice, it's intuitive, but the downside is, yeah, it is a web interface. It is click, 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 and at the end of the day, I probably don't know what exactly I have set up. It's not reproducible, and yeah. I definitely cannot add it under a version control or something like this. Oracle provide a bunch of other methods to provision resources in the cloud. First of all, I can use the command line interface, the OCI CLE. I can also use REST APIs, and I can even use an OCI SDK. So basically, the command line interface wrapped into one of my favorite languages like Python, Java, etc. The downside of this is that I am responsible for everything. I mean, Oracle does provide me the interface to create a network resource, to create a compute instance, to create a block storage. But I have to make sure that the dependencies, the sequence is in the right order, so I have to care about everything. Yeah, so really, as I said, it's more like the imperative. So I really explicitly define everything rather than just say, I want to have a network with a compute instance. And please, Oracle, do this. I don't want to care about if I now have to create the network first before the compute instance, or if I have to create a block device before, etc. So this is something which I would like to avoid. And here we come to a point where we to a keyword. It's infrastructure as code. So I'm going to describe my environment in some kind of a language. There are different possibilities. It's a key best practice in DevOps. I can use different kind of products. At the end of the day, a command line, an OCI command line interface is as well infrastructure as code. I once did this, write a bash script which set up the whole environment. But as I said, I have to be responsible for every dependencies, etc. There are other ISC tools like Chief Puppet, Ansible, CloudFormation, and Terraform. And one special thing is Terraform. We will see it later on, that I really can define my environment in a form that I don't have to care about a couple of things. So Terraform in a nutshell is making Mars to Earth, so forming the environment that everybody can live on it. So this is a term which has been around in the later oops, sorry, wrong direction, in the later 90s. So the Generation X, we know there are a couple of science fiction movies, books, etc., which where Terraform was a topic. In particular, Total Recall was one of the movies. But for millennials, more or less, it's completely different. It is a software product by HashiCorp. It has been released in mid-2014, and it's currently in stable release 0.15.4. And it is a pure tool to describe an infrastructure with a software tool. So I have a declarative language where I really can describe my environment, and the backend and the provider, who will see what's this a bit later, will care about how to set it up in the cloud. Terraform will then use some kind of functionality to build, change, and also to destroy an environment. It's also a bit wondering to rule them all, so I can configure more or less everything with Terraform as long as I have it specified within my provider. Terraform is declarative, so it's not procedural language, so I really describe my environment, and based on my description, Terraform then creates an execution plan, and it starts to build the desired infrastructure. And Terraform takes care about the sequence of the components, and it also makes sure that when possible, certain resources will be built in parallel. So if I want to set up 4 VMs or compute instances, the Terraform will create them at the same time, not in a sequence, to speed up the provisioning time. Basically, the language is some kind of generic. On one side, so it's cloud agnostic. So I have a similar language if I use it for Azure, for AWS, for Oracle OCI, and a bunch of other cloud providers. But at the end of the day, the work is done by the cloud provider, so the piece which is then deploying the stuff in the cloud. There are methods that I can really create a generic Terraform configuration, but this is quite a special case. So at the end of the day, I have a dedicated Terraform configuration for every cloud environment, but it looks similar. So I create a resource in more or less a similar way as I do it in OCI and in Azure. To know that what's going on, Terraform maintains a so-called state file. So Terraform, on one side, I have the configuration, which describes my environment. And on the other side, I have this state file, which is a representation of the current situation in the cloud. So the state file is then used by Terraform to see, oh, I have the configuration on one side. Oh, there has been a change in the configuration. I have to adapt the change in the cloud. As I said, I have a bunch of components. I have on one side this configuration language. Then I have the provider. This is basically the API, which is used by Terraform to interact with the different cloud resources or cloud providers. They are telling Terraform how to build certain resource types. They are usually maintained by the cloud provider itself. So an OCI provider is maintained by Oracle, and an Azure provider is maintained by Microsoft. There are a bunch of generic providers which are maintained by Terraform itself, but yes, the provider itself are usually maintained by the different cloud providers. They are available via Terraform Registry. You can also access everything via GitHub to see what the provider. Then the third component, which is quite important, is models. So every kind of infrastructure can be put together in a so-called model, so that if I want to set up a jump host and I want to do this again and again, without creating every time the same configuration, I can put this in a model which I can reuse for all my environment configuration. There are different kind of models. You find public models in the Terraform registry, and you also find a bunch of models in GitHub, and you can create all models locally or in GitHub and access them. Then the last component, which is quite important, is the backend itself. It's quite important how Terraform interacts and how Terraform maintains the state files in particular. Like if you want to share environment, and if I set up Terraform in OCI, and I work together, for instance, with Martin Berger, and we are working in the same environment, and then if we would have our own state file for the same environment in the cloud, it doesn't make sense, because then if Martin is deploying something and I deploy something, then we have a different setup and different state. So therefore, there is the backend functionality then that you can create a state file in the cloud, so that the information how the setup is done is definitely in a shared location. Here, that's just a print screen of the Terraform, of the Terraform registry, where you can browse for providers and models, and it's really straightforward. I can just move this over. You should see now my browser window. The important thing, these are the feature providers, so the one which are quite used quite often, the Oracle, AWS, Google Cloud, etc. And if you check this, you see the provider information and information about the update. This is also the place where we found the documentation for this particular provider. So for OCI, we have the documentation, and we see what kind of resources we can create. That we see, we have core resources, and then we have examples. So everything is in there. Beside this, you also find the link to the source in GitHub. So basically, you can even go there and check how Oracle wrote the Terraform provider in OCI. The provider and Terraform itself, they are written in Golang. So basically, you can also create your own provider for any kind of environment. Then Oracle has multiple providers. The currently most important one is the OCI one. There are also for the a bit legacy one, the classic provider. But currently OCI one is the one which is used and should be used for setting up Oracle cloud-based resources. This is what I just showed. Terraform and other ISC tools. Terraform is used to create immutable infrastructure. I'm going to describe the infrastructure, define the procedure, rather than defining the procedure, how to provision it. So Terraform itself takes this step and make the plan how it is provisioning. And it has the focus on provisioning the environment, not on configuring. So compare it with Ansible. Ansible is then more to configure and set up an environment, install the database software, configure a database, etc. Where Terraform is more the tool to really set up the basic infrastructure resource without installing a patch on a Linux system, or creating user, installing software, etc. On the other hand, you can also use Puppet and Ansible to deploy resources in the cloud. So if I put everything together, now we have as a base, we have somewhere our Terraform code, our configuration, setup script, whatever. On top of it, then we have this Terraform configuration, which we're going to use to apply the environment. This is done via command-line tool. I can do this with a build pipeline in Azure DevOps or Git action. I can also use OCI SDK. We'll see this later on. Then I have the initialization. So Terraform itself provides an interface that I can do a simple initialization of a resource, telling if I create a VM, please create a user, set up this and that script, do a YUM update. But as soon as it gets complex, like installing an Oracle database, configuring an Oracle database, then it makes sense to combine this with other tools like Ansible. And at the end, if I run everything, I can deploy it in the cloud, and then it's up and running, and I can use it. So first steps. First of all, if I want to start, I have to install Terraform. I do my stuff on my Mac OS. You can do this on Linux as well. Terraform itself is also available on Windows as a command line. So here it's just the way how it is. You do a simple installation on Mac OS with brew. Takes a couple of minutes, then you have it installed. Then something else which is important is that you have to do a configuration with OCI. So you have to store your key of OCI locally, so that Terraform is able to access the OCI with the user account. So Terraform needs the user key, the public key, and also the information about the tenancy, etc. So basically, beside the PM here and the public key file, respectively the user, the key file which is configured for OCI, you also have to specify the tenancy OCID, the user OCID, the fingerprint, and then also the region. So we have to tell Terraform in which region we would like to work. Like, should we create our resources in Zurich, or would you rather prefer to create it in Frankfurt or London or somewhere else? Yeah, then we put this together and set up a provider. I can show this now here as a simple one-to-one. Then we see how we can do it also differently, in particular when we start to use more complex setups. So we have to set up a file. It can have any name. And within this file, we define provider OCI. We provide the tenancy OCID, user OCID, fingerprint, the path to the private key of the user which is accessing it, and the region. And then we can start to go ahead. So you should see now my environment. Here I have a short demo. We have 3 files. Basically, one important file, that's the provider file. It's same as I said it before in the PDF, but the difference here is, you see, I don't specify them hard-coded here anymore. I put them as a variable. And beside this, I have another file called variable. And here I define a variable for OCID, fingerprint, private key, etc. But you see, there is nothing defined. So there is just the name, the type, and the description, but no values defined. This means I have to provide this value, and I can provide this value either by specify them when I run Terraform, or I can provide it within a Terraform vars file. Here we have the vars file where I say, okay, my variable region has the value EU Zurich 1. The third option is I can define it with the environment variable. the var. And you see it here. There is a variable prefix tf_var, and then the value of the name of the variable, fingerprint, and then the value. So I set it via environment variable. This is usually done because I don't want to store my fingerprint and my tenancy, OCI ID, etc. in a Git repository. So that's on my PC, that's my personal stuff. And that's for instance, different for a colleague. He has another user OCI ID, another private key, and that's why you don't store it in a file. So just provide it as a variable. Okay. Now you see there is nothing else. The first thing which we now have to do is Terraform init to initialize Terraform, and it will initialize the backend, and it will download the latest plugins, etc. And as you see now, we have here a file called a folder called Terraform, and within this folder, Terraform downloaded all the information, the provider which is used for this setup. And we see that if we download, there is the bunch of folders, subfolders, and somewhere we see OCI. So Oracle just downloaded the OCI provider. This is the same which we can see it here. So Terraform init just downloaded it from the registry. The next thing which we usually do, if you have such a configuration, we do a validate to see if everything is fine. Just as a test, if I have an error here, for instance, I can add an extra T, and I run validate again. It says, oops, oh, it was a bad ID. Change something else. No, configuration is valid, so I don't have any syntax. Oh, no. Do another simple error here. I see now I did argument block is not defined, so I had a typo, so I have to fix this. This just as an example to oops. Yeah. Something else. Terraform also is quite has the functionality to format everything. So I did the validate now, so it is fixed now. You see, there is no error anymore. And what I can do now as well is using Terraform FMT format. It shows me that it did update the formattation of the file. So you did so before that I removed some blanks. If I do a cat on the file, you see it did organize everything again. It beautifies the code. So now it's ready to deploy the environment. Run plan. You can specify mount. Mount file. There is no change because I don't have really something to deploy in this case here. I can also do an apply, but since I only have the variable file and there is no resource created. So for this, I have the second file. I can do a Terraform init here again. And here it will do a bit more because when you check here my folder, I have a data source defined. So it gets some information. Data source is always getting querying information in OCI, and I define some output variables here. to display information as well. So when I did run a Terraform apply, it just changed the output and showed me the output. I can also now run a plan of this, because I can apply the plan. And here, because I just have a query command, so a data command, it just provides me the output. And I did query for the compartment name and the compartment description. And I also query for an OCI image where it creates a query and look up some information. Here I have a bit more in the main. I have created a model, or added a model, Trivadis Lab VCN. So rather than creating the VCN manually, I just use this model to create this VCN. And if I run here now the Terraform, init, you see it will download a bit more information than before, because it also did download the corresponding model. And if I run now Terraform plan, we will see that it creates the plan, and now we see here, it will add 10 resources, nothing changed, nothing to destroy. And here we see that it will create a VCN with the subnet, public subnet, private subnet, etc. And if I run the apply, it does create, you see, it does create it, and you also see that it will create a different kind in sequence. It's done already. It already created these 10 resources, and it provides the output. So I have it already created. As we are a bit short on time, I go back to my presentation. So coming to few use cases. I have a bunch of possibilities. So I mentioned the provider again, so you can check what kind of resources can be configured, and Oracle is updating them quite often. So if there is a new resource type, it will be updated here in the provider as well. But when you start, you have to create some short infrastructure configuration to start with. You need a VCN, then you can configure your autonomous database, OCN, etc. So there's a bunch of work. It makes sense to consider models. So if you can have a look what kind of models are available. Oracle provided a bunch of models which can be used. It simplifies just to set up the certain resources, and you don't have to care about everything. And it's easier if you create always the same DB server, that you can always create them based on these I did show in the example before. And here you see the module itself, the VCN, which I showed before in the registry. You have all information there. Yeah, Jan, I know I'm a bit short on time. Have you had some questions so far? No.
We don't have any questions.
Okay, then I can spend the next 5 minutes. I did create a bunch of modules for Trivadis, for Bastion host, jump host, DB server, etc. They are public available. And the interesting part is they provide some additional stuff like SSH access, guacamole access, and we see it on the next slide, that we have, that you can easily set up with just 2 modules, a compartment including the public and private network. In the public network, we have the jump host. In the private network, we have the DB server. So the DB server is protected, and so on. And that's quite simple to set this up based on module which are provided by me and by Oracle. And this is also how we did start to set up in Trivadis the lab and trainings environment. So if you have a lab, use OCI, use Terraform. we set up the VCN, we set up a Bastion host, and behind the Bastion host, we then set up different compute instances for backup recovery training, for a toolbox development environment, etc. And the cool thing is that with Terraform, I didn't mention this so far, you can also scale it. So you can just say, oh, I have now this environment, which you see on the screen now with a database server, with the Active Directory server, with the Unified Directory server and the jump host. I want to have this environment 10 times. Then you just tell Terraform, please create me this environment 10 times, and Terraform will create this environment 10 times, and you don't have to care about those stuff. Terraform will just create it for you. Yeah, this is just a short preview. Our Bastion host is set up in a way that we not only provide SSA access, we run a web server on it with Guacamole, so that you can log into this Guacamole environment, and then you can access the lab environments via this jump host via web browser. This is really handy and practical if you set up lab and test and POC environments. So I'm going to finish my presentation with a few good practice. Some of them I already did show or mention. So it makes sure that you really start to use Terraform quite early when you start your OCI journey. So it makes sense to look into Terraform quite early on one side. And then on the other side, if you use it, really start to use it with a version control kit or something else. This is quite a good practice. Then configure the backend for the state file so that you use not local state file, in particular when you have shared environment where multiple users are working on the same Terraform configuration. Then it really makes sense to have a shared state file in OCI, for instance. Then always use the latest version because this is supporting different things like loop counts that you can scale the environment. And also make sure that your Terraform configuration file are really simple. I did show this before, that we just have a few files. I mean, my provider file is really simple. Sorry. Here, it's really simple, and Terraform doesn't care if I have 100 files, but then you have a proper naming, you know that's the provider. And there is the instance, there's the database server, etc. You can also put everything in one file, but then die Übersichtlichkeit is not and then be careful if you run an apply, because sometimes it will destroy your environment. So that's always if we run a plan here that we see, just scroll up. Sorry, that you check what is destroyed and what will be created before you destroy your production environment. Then let's start to think about other things like on top, like if you deploy your environment, you have to configure it. So more probably makes sense to look into Ansible or the Packer from Terraform from HashiCorp itself. And don't invent the wheel again. So use what Oracle is providing. Oracle has a few examples on one side, and Terraform itself has some recommendation, good practice on the other side. So yeah, there's something else. You can also use Terraform interactively with a console, so that directly work on the environment. But I think that's then just a further topic. You can also look into OCI itself. OCI and Oracle itself does use Terraform for their own stuff as well. So if you go through the marketplace or if you create a stack in OCI, this configuration is created in Terraform as well. So you can have a look and check how Oracle is using Terraform. You can upload your own Terraform configuration as well as a stack. So this is really interesting and something which has to be where it makes sense to look into it.
Okay, so even use the 5 last minutes if you can.
Yep.
Conclude, it will be nice. Thank you, Stefan.
Yep. You can put the stack as a cloud button, so you can create even a URL which points to your Terraform configuration in GitHub, and the customer could basically click this URL, and at the end, after a couple of minutes, he will have a created stack, in OCI. So he will have its own environment in OCI just based on a new Terraform configuration which you uploaded to GitHub. I come to my last slide, to the summary. So Terraform is really a useful tool for implementing ISE. It makes sense to have a clear strategy. So what kind of module you want to set up, where you want to set up the environment. So would you like to set up everything in one configuration, or you split it up in different smaller parts? Then also have a look at Terraform good practice. Yeah, so this is really recommended. Then considering another tool like Ansible to configure your resources. So use Terraform to build up the resources, and then use Ansible for configure software releases, databases, etc. on top of it. Then check the resources from Terraform and Oracle. They have really good ideas, good examples. Yeah. And it's fast. The provision usually is quite fast. Sure, if you install an Oracle database, it will take time. It's relatively easy to set up 20 compute instances in one time, and if you still have to wait somewhere, you can still watch one of these old movie discussing Terraform from the other point of view. So I know it was quite a lot of information. You find the slides later on. I also provided a bunch of links to the slides, so where you find the different information like the examples, the libraries, and so on. So if you would like to start with Terraform deployment in OCI, have a look, check out the links, and I wish you good Terraforming.
Thank you, Stefan. The presentation will be anyway distributed afterwards, so the people will get the links. Yeah, as I told, I think I have no question, so at least nobody wrote any in the Q&A. Many thanks for your presentation, Stefan. Many thanks for your participation at the several SUG events. The ones who want to join quickly the stretch and relax in the stream one can use the remaining 7 minutes. And for the others, we start in quarter to 4. Thank you again.
See you. Bye. Thank you.